Hi, welcome to Learning Monkey. I am Raghu here. In this class, we'll discuss about the concept of order of a group and order of an element. In our previous classes, we already discussed the concepts of groups, and this is the extension concept. We are going to use these concepts in our coming classes. So please watch our previous classes and come back here. The link for the playlist is provided in the description below. Coming to today's class, these are very simple concepts to understand. The order of a group is given as number of elements in a group. We call it as order of a group. So the number of elements in a group. Here in our situations, we are going to consider Zn star groups. These are the examples which we are going to use, which we already used in our previous classes. What is Zn star group means? The elements less than n and relatively prime to n. These elements belongs to that group, and the operation that we are going to use on that group is a multiplication operation. So for these groups, we are going to identify the order of a group. So Z10 star means the elements that are less than 10, that are relatively prime to 10, 1, 3, 7, 9. So the order of a group is, order of this Z10 star group is 4. This is what we call it as phi of n, Euler's totient function. Phi of n means the elements that are less than n and relatively prime to n. We call it as phi of n. So if you want to identify the order of a group, it is the phi of n value. In our example, because we are considering these type of groups. So don't forget this, otherwise you are going to make a mistake. So order of Zn star is given as phi of n. So let's take one example. Order of a group Z21 star over multiplication is phi of 21. 21 can be written as multiples of prime factors. 7 multiplied by 3, which is so 7 minus 1 you got 6, 3 minus 1 you got 2. So 6 multiplied by 2 is given as 12. The order of a group Z21 star is 12. So this is what order of a group means. Now we need to understand what is meant by order of an element means. Order of an element, first understand the definition. Anyhow, you will get good clarity with example. The order of element A, you take that element A is the smallest integer I. Order of element A is the smallest integer I such that A power I congruent to E mod n. If it satisfies this equation, then I is called as order of an element. So here E means identity element. If you consider these type of groups, for multiplication, what is the identity element? 1 is the identity element. So A power I congruent to 1 mod n. Let's do some examples. G or group is considered as Z10 star over multiplication. The elements that belongs here is 1, 3, 7, 9, and the order of 1 is 1 power 1 congruent to 1 mod 10. 1 power 1 means 1 congruent to 1 mod 10. So the smallest I, understand this properly, this is very important. Smallest I, after 1 there are so many values are there, but this is the smallest value. So our I value is 1. That's why order of our element 1 is 1. Similarly, order of 3 is 3 power 4, 81, congruent to 1 mod 10. Yes, 81 mod 10, which is 1 mod 10. That's why the order of element 3 is 4. Similarly, order of 9 is 9 square, 81, 81 1 mod 10. 81 mod 10 is 1 mod 10. That's why order of 9 is 2. So this is what you need to understand, but for better understanding, for connecting the classes, you just think of this also. From the Euler's theorem, what's the Euler's theorem says? A power phi n congruent to 1 mod n. If n and a are relatively prime, then only this Euler's theorem applicable. Here in our example, in our group, n and the element, whatever element you consider here, all those are relatively prime to n. That's why a power phi n is definitely going to be 1 mod n from the Euler's theorem. In this order of means phi n, you call it as order of element A, but the minimum value you need. So from this you need to understand that at least one value exists, that is phi of n. This is the point you need to understand from Euler's theorem. Definitely you are going to exist at least one value, one I value that gives 1 mod n. That is what this Euler theorem says, that applicable here. For each element, definitely it is going to have one element which is phi of n. Hope you understand the concept of order of a group and order of an element. If you have any questions regarding the concept, please post your questions in the comment section below. Thanks for watching. If you haven't subscribed to our channel, please subscribe to our channel and press bell icon for the latest updates. Thank you.